Day 30, Automatic Essay Grading using BERT. The project overview is to build an automatic essay grading system using BERT, which is bidirectional encoder representations from transformers, to evaluate and assign scores to essays based on their content, coherence, and relevance. The prerequisites here is make sure you have some of the libraries installed like Pandas, Scikit-learn, Torch, Matplotlib, and Seaborn. If you have already been working with us since following along with until day 29, you should have all of them installed. Now for dataset, we'll use the automated student assessment prize ASAP dataset available on Kaggle. The key features in the dataset is essay and score. Essay is the text of the essay and score is the grade score assigned to the essay. So if I go over here, I already have the day 30 folder where I have two files. One is the Python file and the other is the CSV file that I downloaded from Kaggle. And here we have the essay and the overall score for each one of them. So if you see this one has overall score of 5.5. This is the next one which has of overall score of 6.5. This is the next essay with all that information and the essay score at the end of it. So for every single thing we have a score at the end. So there's two different fields, essay and overall. So that's what we have. Now let's go ahead and implement our code to do essay grading using BERT. So the first thing that I need is, as usual, the libraries. So I'm going to go ahead and import the required libraries. We would need Pandas, which is data manipulation and analysis library. We'll use NumPy, which is numerical competition library. We'll get the trained test split from sklearn.model selection, which splits the dataset into training and testing sets. Next, we'll need standard scalar from sklearn.preprocessing. This thing standardizes the numerical features. Next, I'm going to get the mean square error and R2 from sklearn.metrics. Now this mean square error measures the mean squared error of prediction, whereas R2 score measures the proportion of variance explained by the model. Next, we import matplotlib.pyplot as PLT, which is a core plotting library for visualizations. Next, I'm going to import Seaborn as SNS, which is an advanced statistical plots library. Then we're going to import Torch. This is the PyTorch library for building neural networks. Next, I'm going to get dataset and data loader from torch.utils.data. This dataset is an abstract class for data loading, whereas data loader is what it does is efficiently load data into batches for training. Next, I'll need BERT tokenizer, BERT model, and Adam W. The BERT tokenizer for text pre-processing using BERT, and BERT model is the pre-trained BERT model for embeddings, and Adam W is optimizer for training the neural network. Next step, let's go ahead and load and explore the data set. So first, I'm going to say df, which is a data frame, equal to pd dot pandas dot read csv essays dot csv. So I'm loading the entire data set. So pd dot read csv, as you know, reads the essays dot csv data set into a pandas data frame. Next, I'm going to say print dataset sample, and I'm going to print df dot head, where I'm displaying the first 5 rows of the dataset. Next, let's go ahead and select some relevant columns. Now I have only 2 columns, which is from data frame essay and overall. Now this selects only the 2 columns that we have. Essay contains the text of essays, as you saw in this essays.csv, and overall is the numerical score assigned to each essay. So that takes us to the next step, which is pre-process the data, where I'm going to say tokenizer equal to BERT tokenizer from pre-trained BERT base uncaged. This loads the pre-trained BERT tokenizer for lowercase English text. That's what it does. Next, I'm going to go ahead and create the custom dataset class, where I'm going to say class essay dataset. I'm going to first start with the initializer method. I'm going to say def init self essays scores tokenizer max length equal to 512. These are the different variables that I will initialize. Now init initializes the dataset with essays, scores, tokenizer, and max sequence length when it starts up. So it's going to say self dot essays equal to essays, self dot score equal to scores, self dot tokenizer, self dot max length equal to max length. And next step is creating the length function, which returns the number of essays in the data set. So for this, I'm going to say return length of self.essays. Next function is get item, which retrieves a specific essay and score, tokenizes the text, and converts data into tensors. That's what this does. So for that, I'm going to say essay equal to string of self.essays index. I'm going to get that essay. Score equal to self.scores of index. Encoding equal to self.tokenizer encoder plus. Now encoder plus tokenizes the essays and returns. So it will take tokenizer the essay and return back, like I'll say add special tokens equal to true, max length equal to self.max length, padding. These are different parameters that it needs. Padding, truncation, and then return attention mask true, return tensors equal to PyTorch. Now this returns input IDs, which are numerical IDs of tokens, attention mask, which is the identifies real token versus padding, and score, which converts essay score into a PyTorch tensor. So that's what I'll be returning here. As I mentioned, input IDs, which are numerical IDs of the tokens. Attention mask again is identifies the real tokens versus padding, and score, which converts essay score into a PyTorch tensor. Next, I'm going to go ahead and split the data set now. So I'm going to say train text, validation text, train scores, validation scores equal to train test split, data frame. I pass essay, which is my feature, whereas df overall, which is my target, test size equal to 0.2, so 2080 split, and random state equal to 42. That's what I'll assign here. Again, train test split splits data into 80% training and 20% validation based on my specification here. Next, I'm going to say train data set equal to essay data set, and as you know, essay data set takes these are the different parameters, which is train text dot to list, train scores to list, and tokenizer. Our validation data set equal to essay data set, again validation text dot to list, validation score to list, and tokenizer. So this creates instances of the essay data set class for training and validation. Next, I'm going to go ahead and create the data loader. So I'm going to say train loader equal to data loader train data set batch size equal to 8, shuffle equal to true. Next, I'm going to say validation loader equal to data loader val data set batch size equal to 8. Now the data loader efficiently batches data during training and validation, whereas batch size equal to 8 processes 8 samples per iteration. You can increase or decrease depending on how much you want to do. Next, I'm going to go ahead and build the model. So I'm going to say class easy grading model torch.nn.module. I'm going to create the initializer function first, and then here I'm going to say super, call the super method easy grading model comma self, and call the initializer self.BERT equal to BERT model from pre-trained BERT base uncaged. Here I am loading the pre-trained BERT model, which extracts the embeddings. Then I have self.regressor equal to torch.nn.linear self.BERT.config.hidden size comma 1. This is a linear layer which reduces BERT's output to a single score. And finally, I'm going to write the forward function, which is self input IDs comma attention mask, which will have outputs equal to self.BERT input IDs equal to input IDs, attention mask equal to attention mask, CLS output is outputs.puller output, score equal to self.regressor CLS output, and return score.squeeze. Now this forward processes input tensors and returns predicted scores. That's what we do here. Next, let's go and initialize the model, optimizer, and the loss function. So for that, I'm going to say device equal to torch.device CUDA if torch.CUDA is available, else CPU. So depending on your machine, it will set that. Model equal to essay grading model to device. Next, I'm going to say optimizer equal to Adam W model.parameters LR equal learning rate equal to 2e minus 5. This is optimizer for training. And then finally, our loss function equal to torch.nn.msc loss, where MSc loss measures mean square error loss. Now let's go ahead. It's time to train the model. I'm going to create a function train, which takes inputs as model, data loader, loss function, optimizer, and device. And we have all of these. So first, we'll set the model in training modes by saying model.train. Total loss initially is set to 0. Now for batch in data loader, so for each and every batch that we have created, we'll say optimizer.zero grad. This will zero out the gradients from before. Input IDs equal to batch, input IDs to device. Attention mask will be from batch, attention mask to device. Scores will be batch score to device. Finally, outputs equal to model, input IDs equal to input IDs, which we have above, attention mask equal to attention mask, which we have above. Then we'll set the loss equal to loss function. It needs outputs and scores, which is available here. The scores are available here and outputs are available from here. Next, loss dot backward, optimizer dot step, the usual steps, and total loss plus equal to loss dot item. And finally, I'll return total loss divide by length of data loader, which performs a forward pass, calculates the loss, and updates the weights. So this will bring us to evaluation of the model. So let me move it up. For this, I'm going to create a function evaluate, and it will take input as model, data loader, loss function, and device as parameters. I'm going to set the model in evaluation mode. I'll set the predictions to empty, true scores to empty, total loss equal to 0. Now with tosh.nograd, I'm going to go ahead and run a for loop over the data loader for each batch, and I'm going to say input IDs equal to batch of input IDs to device, attention mask same, batch attention mask, score equal to batch score, same as what we did above, but just this time it's for evaluation. Same thing, outputs equal to model, input IDs, attention mask, loss equal to loss, outputs and scores. Then we go ahead and total loss plus equal to loss dot item. I'm going to get the predictions, extend output dot CPU dot numpy, true scores dot extend score CPU numpy, and then we'll calculate the MSE, mean square error, and pass the true scores and predictions. For R2, I need true scores and predictions again, and return the total loss divided by length of data loader, comma MSE and R2. These are three parameters we'll pass back. So this kind of does is evaluates model performance using MSE and R square. So now it's time to write our training loop. So I'm going to say epochs. How many epochs I want? I want 3. This is going to take a lot of time. So when I run this application, I'm going to pause and then come back. But I'm going to take the risk right now. For epoch in range of epochs, train loss equal to train model, train loader, loss function, optimizer, and device. I'll pass those. For validation loss, MSE and R2, which is passed by this evaluate, I'll say evaluate, pass the model, validated loader, loss function, and device, and it will return back all these parameters assigned to them. Finally, I'm going to say print epoch plus 1, depending on which epoch it is. I'm going to do one epoch print at a time. Train loss, whatever train loss is, validation loss, and MSE R square, I'll be displaying them out. Finally, step 6, which is to test the model. So I'm going to say test text equal to, this is the essay that I have written, or a small essay. The essay provided insightful analysis of the topic with well-structured arguments. You can do whatever you want. Put some text in there, get it from somewhere, and put it over here just for testing. Encoding equal to tokenizer.encode plus text, text, add special tokens equal to true, max length 512, and padding equal to max length, and then I'll say return tensors equal to PyTorch. So set those up. Next, I'm going to go ahead and say input IDs equal to encoding input IDs to device. Next, I'll create the attention mask, encoding attention mask to device. Next, I'm going to say model.evaluation. This will evaluate and test the model and will give us the outputs accordingly. Next, I'm going to go ahead and say with torch underscore nograd predicted score equal to model input attention mask item. Then I'm going to print the predicted score. This will give us a predicted score. Based on this essay that I have, it should have somewhere around 4 to 5 points. That's what the score should be. Visualize training data. Finally, this place where we are going to plot training and validation loss over the epochs. So I'm going to say losses equal to epochs 1 to 3. Train loss 0.3, 0.2, 0.1. Validation loss is 0.35, 0.25, and 0.15. Loss data frame is pd.dataframe losses. SNS dot line plot. I'm going to display a line plot which will look like more of a slant line for both the training and validation. And I'll have line plot data loss, x epoch, y is train loss, and label is train loss. Now SNS line plot for another one, I'll say loss df, data frame data, epoch. This time it is the validation loss and validation loss as the label. Then I'm going to say title is training and validation loss, and I'll say plot dot show which will show the plot to the user. So that kind of wraps up our entire application. So we have completed everything here. Everything has been added. Now let's go ahead and test it out. Let's see if there's any errors, any typos, anything. So I'm going to open my terminal, and here I'm going to say python day30.py, run it. As I said, it's going to take some time because it's going to run for 3 epochs, so have some patience. Maybe take 30 minutes or an hour to run this, as it's displaying the data sample and initial stuff. So that's what it's going to do. Now it's going to run through the 3 epochs that are there and then come back. So I'll pause it here and come back once this is complete. So there you go. It took some time, but we have our results over here. And here is our graph for training and validation loss with each epoch. And then we have right here all our information. As you can see, we saw the dataset sample earlier, but below it we have our epoch 1 where training loss was 6.89, the validation loss was 0.69, MSE was 0.69, and R2 was 0.333. Epoch 2 training loss was 0.75, which reduced quite a lot. And then the validation loss was 1.19, MSE is 1.18, R2 is minus 0.14. And after epoch 3, our training loss was 0.53, validation loss was 0.91, MSE 0.91, and R2 is 0.165. Our predicted score here is 4.23, which is our score for the essay grading. So we have in this project pre-processed essay text data. We built a BERT-based regression model for essay grading, and we evaluated and visualized the performance right here. So this project demonstrates how deep learning models like BERT can automate complex tasks such as essay grading. If you have any questions or had any issues implementing this, let me know in the messages and I'll get back to you. Thank you.